Okay, this is Miss Rivera, and I'm going to do a series of videos to help those of you who have not been in class the last few weeks. 5.2, 5.3, and 5.4 are probably our most complicated sections, so I just wanted to give you the lectures on video format so that you can stay caught up. Remember that even though you are away at tournaments, I still expect you to be doing your work in your spare time and staying current with us. Simply put, in math language, for any polynomial of x, if we make a function equal to 0, we can solve it and find the x-intercepts. Okay, so that's any function. I gave you this one as an example, but what this says is for any polynomial in terms of x, if we make a function equal to 0, we can solve it to find the x-intercepts. The x-intercepts are also known as zeros, solutions, and roots. And throughout class, I'll be saying one or the other. I'll say, okay, let's find the solutions, let's find the roots, let's find the zeros. We're doing the same thing. It's just those four words are synonyms. Okay. Some examples are, let's find the zeros of each function and graph. So here we have a simple quadratic function. We want to make sure that it's equal to 0. Then we factor. Then we set each factor equal to 0. Because if I can make this part equal to 0, then my whole equation is equal to 0. Just like if I could make that second factor equal to 0, then my whole equation would equal 0. Once we've done that, we use our zero property rule and we find the numbers that would indeed make a factor equal to 0. Those, remember, once we find those, remember those are our x-intercepts. So what we're talking about is to find the points on the graph where it crosses that axis. So to graph this, we ask ourselves, is this an odd or even function? We notice that we have an even leading exponent, so we know that it's an even function. The coefficient to that exponent is positive, so we know that it's a positive even function. What this means is that the end behavior will be up and up. We did that in section 5.1. So what we do is we graph our zeros, those are the red dots, we do our ending behavior, and then we connect the dots in between. And that gives us a graph of our function. You can find how far down you're going to graph right here by using your graphing calculator. And you want to look for, if you'll look at online in your textbook or just Google it, you want to look for a relative, minimum, or maximum. And what that means is you're looking for that value that is either lowest or highest within a given range, a given set of data. The most important thing that I want you to know how to do out of this is to graph the end behavior, to find the zeros, and then how you're going to join them. Connecting the dots is not always as simple as joining dot to dot. We have to think about what is a factor's multiplicity. And the multiplicity just refers to how many times a factor occurs. If we had x minus 7 cubed times x minus 4 squared, we would say that x minus 7 had a multiplicity of 3 and x minus 4 had a multiplicity of 2. Okay? And this determines, the odd or even multiplicity determines whether or not it crosses the x-axis. If it's an odd multiplicity, then it gives you the point on the x-axis where the graph crosses. Goes from one side to the other, goes straight through the x-axis. An even multiplicity gives you a point where the graph touches and turns on the x-axis, so it won't actually cross the graph. Let's see what this looks like. Example, if I have f of x, I have a polynomial in terms of x, and it's equal to x plus 3 times x minus 2 times x minus 2. this is going to be the polynomial. And I've already put it in factored form, so we didn't have to factor it out. Okay, so we know that our zeros will occur at x plus 3 and x minus 2. So when x is equal to negative 3 and x is equal to 2. X is equal to negative 3, we only have a multiplicity of 1. With x equal to 2, we have a multiplicity of 2 because that factor occurs 2 times. So to graph this, we look at our leading term. We find our leading term by just multiplying the first term of each factor. So we know that our leading term is going to be an x cubed, and it's going to be positive. So it is a positive odd function. We know that our roots are going to occur at negative 3 and at 2. So what I did is I graphed negative 3, I graphed 2, I did my end behavior, just like before, and then I looked at the multiplicity. I know that since it's an odd multiplicity at negative 3, that my graph goes straight through, and then here at 2, I just touch and turn. So now I want you to refer to Orban, and I want you to look at the homework that was assigned for section 5.2. Okay. If you have any questions, you know that you can always text me through Remind. Remember, I send you those messages. Or you can email me through Orban, or email me directly at karen.rivera@img. See you when you get back.